Okay, so first we're going to start off with multiplying and dividing. Here are the instructions you must follow. First, you have to factor each part if possible, meaning you have to factor the numerator and the denominator. The second part is simplifying. Remember that you can always simplify monomial with monomial, binomial with binomial, and trinomial with trinomial as long as they match exactly. Okay, so here is our first problem with multiplication. I'm going to go step by step and explain what I did to solve it. So this is our original problem. Okay, as I mentioned before, the first step you must do is factor each one. So for the first part, we know that we can factor a 2 and an x. And that would leave us with a 2x and x minus 1. For the bottom, we know that we can factor that into two factors, 2x minus 1 and 2x plus 1. The second one, we could, again, factor. It would be a 5, and then a 2x and a minus 1. In the bottom, we can't factor out the 4x, so that would stay the same. Then we would combine them. So we combined all the denominators over here, and then we would combine all the numerators up top. We have the 2x times the 5, and that gives us a 10x, and we know we're not going to multiply each one, so they just cross over. After that's done, we can see what we can cancel out. And remember, we can only cancel out if it's the same exact monomial, binomial, or trinomial on the numerator and on the denominator. On the numerator, we have the 2x minus 1, and it's also in the denominator, so that cancels out each other. We also have an x, and it's the same monomial, so we cancel those out. We also know that we can simplify a 10 and a 4, and they both divide by 2. When divided by 2, that gives us a 5 and a 2. And then what we have left is the binomial x minus 1 and 2x plus 1. And that is how you multiply. I'm going to talk about division. Now, hearing division might freak some people out, but it shouldn't because it's the same thing as multiplying. We can't divide. So what we're going to do is we're going to flip the second fraction and change the sign to multiplication. And that's what we're going to do. So this is what we did here. We had the x squared minus 1 in the denominator, and we switched it to the numerator. The 6x minus 10 in the numerator, and we switched it to the denominator, and we switched the sign from division to multiplication. Then we're going to factor, just like we did in multiplication. The 9x minus 25 factors out to a 3x minus 5 and a 3x plus 5. And we know this because if we multiply them back together, it'll give us a 9x minus 25. So now we factor out the denominator, and that gives us a 2 and an x minus 1 because we can factor out a 2 from here. Then we move on to the second one. So out of the x squared minus 1, we have an x minus 1 and an x plus 1. Again, if we multiply these two factors together, it would give us x2 minus 1. And then in the denominator, we have the 6x minus 10, and we could get out a 2 out of there. And once we do, we factor out the 2, it leaves us with a 3x minus 5. Okay, easy enough, simple enough. After that, we will combine them together. And that's right here. We have the denominators, the 2 times a 2 is a 4. And then we combine these two in the denominator. Then we do the same thing, and we put all the numerators together in one line. After that, we see which ones cancel out. Again, monomial with monomial, binomial with binomial, if they match exactly. So here we have a 3x minus 5, and we have a 3x minus 5, so these two cancel each other out. We have a 3x plus 5, but we don't have that in the denominator, so it will stay. We have an x minus 1 and x minus 1, cancel out. We have an x plus 1, but we do not have that in the denominator, so that stays. And then after canceling each one out, it might look messy now, but wait and see. This one cancels out. This one cancels out, this one cancels out, and this one cancels out. So now that's what you have left, and that would be your answer. We have left a 3x plus 5 in the numerator and an x plus 1 in the numerator as well, and then in the denominator we just have an x plus 4. And that is how you divide. It's the same thing as multiplying. So now we're going to talk about adding and subtracting. Now there's basically just two rules you have to follow. The first one, and the very important one, is you have to make sure you have a common denominator. If not, you can't add or subtract. And the second rule is just to simplify as we've been doing before. We're going to start with adding. Here's a simple one to start you off. We have 11p plus 3 over p minus 1 plus 4p plus 1 over p minus 1. Now, the first step was to make sure we had a common denominator, and in this case we do. So that's easy, that just passes by. Now, the second one, we have to combine like terms. Since we're combining like terms and we're adding them, it would be 11p plus 4p, and that gives us a 15p. A 3 plus a 1 gives us a 4. And then we can't simplify this anymore. These are not like terms, so they don't cancel each other out. So this would be our answer, 15p plus 4 over p minus 1. Now I'm going to show you how to add when you don't have the same common denominator. So we see that we don't have the same common denominator, but one thing we can do is factor first. Now we're not going to pay attention to the numerators because they're monomials, so we can't really factor them, so we're going to leave them as they are. But we're going to factor the denominators. So we know that an x squared minus 9 factors out to be an x minus 3 and an x plus 3. Because if we multiply them together, it would give us an x squared minus 9. Now we do the same thing for the denominator on the second fraction over here. We know that an x squared plus 4x plus 3 factors out to be an x plus 1 and an x plus 3. Now, one thing that we can notice right away is that they both have an x plus 3 on the denominator, both of them, so that would be an overlap. Now, when writing all the denominators, we do not want to write more than once. When we combine them all, we don't want to write it more than once, so we just write it once. Now, follow my thought process here. Okay, then we have to think, what does the first fraction, what is it missing from the denominator that the second fraction has? We already know that they both have an x plus 3, so that's not it. The first fraction is missing an x plus 1, so we multiply it by an x plus 1. The second fraction is missing an x minus 3. They both have an x plus 3, but it's missing an x minus 3. So we have to multiply that by an x minus 3. Now, after we do that, we would combine all the denominators together. Again, we don't want to repeat them, so we would just write it once because they both have it. And then an x plus 1 and an x minus 3. Now we combine them and we're adding. So we have 5x plus 5. 2x times x is a 2x squared, and 2x times negative 3 is a negative 6x. After that, we can combine like terms. And that gives us our answer. 2x squared, because there's no other number with an x squared, minus x, because 5x minus 6x is negative 1x, and a 5, and all the denominators in the bottom. And the x plus 3 is just written once because we do not want to write it more than once. And that is how you would solve an addition problem when you don't have a common denominator. And you can always refer back to this problem when you're solving one of these as well. With subtracting, it is the same exact steps as adding. Now, we first look if we have the same denominator, and in this case, we do. So that just passes on. Then we have to combine the numerator, but we have to keep in mind that it's a subtraction, so this negative finds its way to the second numerator. So we have a 5x plus 4, and we're combining it with the second numerator, but we have to keep in mind again that the negative distributes its way. So instead of a 5x plus 3, this turns into a negative 5x minus a 3, and we have the same denominator. Then we combine like terms, and a 15x minus a 5x is a 10x, and a 4 minus a 3 is a positive 1 over an x minus 1. And that is how you would subtract. Now this would be a simple one. I'm going to show you next what you would do when you have a little bit more complicated because you don't have the same denominator. What happens when you're subtracting and you don't have the same denominator, which would be the case in this case? Here you have a 3 over an m minus 4 minus a 7 over an m plus 1. So what we would do would be the same thing as we did before with the addition problem when we didn't have the same denominators. So we don't do anything yet to the numerators, so we would just write them as they are. And then we have to think, do these have any, this can't be simplified, first of all. Second of all, do these have any overlap? There is no overlap because we have an m minus 4 and an m plus 1. Okay, so then we have to think our next step. What does the first fraction, what is it missing from the denominator that the second fraction has? It has an m minus 4, but it doesn't have an m plus 1. So that is when we would know that we would have to multiply it by m plus 1. Then we think about the second fraction. What is the 7 over m plus 1? What is it missing that the first fraction has in the denominator? It is missing an m minus 4. So then we know that we have to multiply it by an m minus 4. And since we multiplied each top and bottom by them, then we already know that the denominator has both of them combined. We can combine them. There's no problem. Then after that, we would go to the next step when we would simplify and multiply. So we multiply the 3 times the m plus 1. 3m plus a 3, because the 3 times m is 3m, and the 3 times 1 is 3. Then we would do the same thing with the 7, but we have to keep in mind that this is a negative. So the negative distributes its way, so it changes the whole numerator. If it were a positive number, it changes it to a negative number. And if it were a negative number, it would change it to a positive number. This is a positive number. So it would be a negative 7 times m gives us a negative 7m. And then a negative 7 times negative 4 gives us a positive 28. Then after that, simple, we would just combine the like terms. When we combine the like terms, we have a negative 7 plus a positive 3, or positive 3 minus 7m. And that gives us a negative 4m. Then we have 3 plus 28, and that gives us a 21. And then we have the same denominators, so they just pass on. And that is how you solve a subtracting problem when you do not have the same denominator.